Welcome to today's explainer. If you've ever been part of a complex engineering project, you already know the universal headache, chasing down disconnected data. Today, we're going to explore how AI-driven reliability and engineering intelligence, specifically looking at the Magnus suite, is fundamentally changing how teams operate. It always starts with a question from leadership that sounds, incredibly simple. Something like, hey, what's the current risk status of program X? If you're the one tasked with answering it, your heart probably just skipped a beat. You know the dread. Answering this simple question usually requires days of manual effort, tracking down different team members, digging through messy shared drives, and trying to mash conflicting data into a single PowerPoint deck just in time for a Friday afternoon meeting.
But we're looking at a fundamental shift in how organizations manage truth right now. The old way is just absolutely painful, relying on emails, fragmented spreadsheets, and literally walking the floor to chase down teams for updates. The new way, though, absolute relief. It's an AI-grounded live system of record. Instead of painstakingly collecting status, you're querying a living database that gives you instant, evidence-based answers.
So, our agenda for this explainer. First, the information island problem. Second, AI-assisted knowledge distillation. Third, linking FMEA, LIMS, and validation. Fourth, real-time risk visibility. And finally, empowering leadership decisions. Let's get right into it.
Section 1. The Information Island Problem. Disconnected Data Silos.
Look, the reality is that most engineering organizations lose hours every single week, not because the data doesn't exist, but because leaders have to constantly hunt it down. The truth is out there, but it's stranded on these isolated islands. You got your lab information management systems, or LIMS. You've got FRACA spreadsheets tracking failure reports, BOM systems, endless FMEA workbooks, physical lab notebooks, and, the deepest black hole of all, email. Because these islands don't talk to each other, getting a clear, accurate picture of your project's true risk requires a massive, highly error-prone manual effort.
Moving on to Section 2, AI-assisted knowledge distillation. Turning data into intelligence.
And this brings us to the core tool of our explainer, the Magnus suite. It's an AI-native reliability and quality platform designed to help teams build safer products, control risk, and close the loop on field issues way faster. Now, it's absolutely crucial to understand that Magnus is not just another database where information goes to die. It's an intelligent operating system that uses AI-assisted knowledge distillation to actively read, link, and synthesize your data. We're talking about saving leaders and teams literally days of manual tracking. Just look at this distillation process in action. The AI assistant is actively reading FMEA data, analyzing risk patterns, and preparing recommendations. This is the exact moment where days of manual spreadsheet auditing just vanish into seconds of AI processing. It immediately focuses the team on what actually matters and clearly shows the risk. Honestly, it's like having a dedicated reliability engineer who never sleeps and has perfectly memorized every single piece of documentation across the entire program. And here's the output, an executive analysis report, like this one for a project called the Aerator Pro. The AI instantly distills 17 different design iterations into a super concise, high-level briefing. It highlights technical advancements, like transitioning to a brushless DC motor or implementing a dual seal design with a Viton primary and NBR backup to improve liquid ingress resistance. For a leader, this is pure gold. You don't have to decipher the technical weeds to understand that risk is actively being mitigated. The AI distills the context, giving you days of your time back. Section 3, linking FMEA, LIMS, and validation, the traceability arc. Now, AI can only synthesize what's actually connected. The Magnus philosophy relies on hardwired end-to-end linkage across these 5 steps: risk, problem, cause, fix, proof. It explicitly connects your DFMEA risk analysis to your LIMS lab test results through validation plans all the way back to the core customer requirements. If you break any link in this chain, you just create another information island. But by hardwiring these together, you create a system where customer requirements are intrinsically tied to actual lab results. Looking here at the FME to test linkage table, you see the visual proof of this architecture. A specific failure mode in the DFME, say FME001, housing cracks on impact, is mapped directly to specific verification tests in the LIMS system, in this case test 001 and test 004. The system even pulls the live risk status and RPN. This entirely eliminates the gap between theoretical design risks, the physical testing happening in the lab, and what the customer actually requires. Because of this deep linkage, when a leader asks, "Where are we on DV testing?" they don't get a vague, "Oh, we're working on it" email. They get a live status pulled directly from LIMS, mapped explicitly to the originating design risks and customer requirements. The answer is instant, and, more importantly, it's completely grounded in the live system of record.
Section 4. Real-time risk visibility. Surface escalations instantly.
So when your DFMEA, LIMS, and validation plans are perfectly linked and monitored, the system aggregates what we call critical risk clusters and immediately flags high-action priority items. For example, check this out. It highlights severe risks within newly introduced electronic and connector modules, like a high risk for short circuits due to connector fluid ingress. It instantly shows the true risk profile and focuses the engineering team's attention exactly where it's needed most, instead of burying critical vulnerabilities on, row 4000 of some forgotten spreadsheet. But pointing out the problem is only half the battle, right? This system goes further by providing actionable AI recommendations for mitigation. To validate electronic reliability for the ADC and CAN bus connector modules, the AI explicitly recommends moving them to active status by executing accelerated life tests, or ALT, and high-pressure wash validation to confirm those theoretical risk reductions. This kind of proactive coaching actively helps the engineering team focus, close the loop, prove the fix, and prevent future bottlenecks.
And because the whole shebang is connected, a leader can ask a really powerful sweeping question like, which suppliers or characteristics are driving our biggest risk exposure right now? To answer this manually, absolute nightmare. But here, the system just queries the entire bill of materials history and past FRACS incidents to spot systemic supplier issues across multiple programs, instantly.
Finally, Section 5. Empowering leadership decisions. Reclaiming hours and driving execution.
The return on investment here is transformational, because AI-assisted knowledge distillation fundamentally destroys those information islands. Massive amounts of hours are reclaimed at the leadership level. Everyone operates from a single source of truth, leading to significantly faster decisions since risk, test, and field data are available in seconds. It provides much better, earlier escalations of systemic issues, saving days of work and constantly keeping the team focused on true priorities. And when it comes to compliance, the AI actively monitors documentation and field data feedback. So if an auditor or a customer asks a question, the AI can instantly provide an answer that cites the original source artifacts, whether that's the specific DFMEA row, the resolve case, or the exact lab sample and LIMS. Every single answer is fully auditable and verifiable, not just a plausible guess. Ultimately, this is the grand payoff. By turning failure data and theoretical risk into verified actions and preventative controls linked straight back to customer requirements, you are directly improving quality, cost, delivery, and cash flow across the entire enterprise. It's all about measurable, evidence-based execution at scale. I want to leave you with a final thought to reflect on regarding your own engineering data systems. Next time you sit down in a major meeting, ask yourself, are your program reviews actually driving decisions, or are they just collecting status? If it's the latter, it might be time to stop chasing data and start letting AI distill the intelligence you need to lead. Thanks for joining me on this explainer, and I'll catch you next time.